Hello friends, in today's exercise we are continuing with limiting reagents. In the last lesson we said that limiting reagent is the reactant that is first used up in a chemical process. And in that previous lesson we determined the limiting reagent using a balanced chemical equation wherein the coefficients were the same. Today, we shall be using a balanced chemical equation wherein the coefficients of the reactants and products are different. In a chemical process, 0.6 mole of sulfuric acid reacted with 0.4 mole of potassium hydroxide to form potassium sulfate and water. Which of the reactants is the limiting reagent? How many moles of potassium sulfate are formed? And lastly, what is the mass of the potassium sulfate formed? In trying to solve this problem, you first present the statement in a balanced chemical equation. Now let us see whether this equation is really balanced. Sulfuric acid reacts with potassium hydroxide to give potassium sulfate and water. At the left of the arrow, you have 2 atoms of hydrogen plus 2 atoms of hydrogen, that is 4. At the right of the arrow, you have 4 atoms of hydrogen. At the left of the arrow, you have 1 sulfate group. At the right of the arrow, you have 1 sulfate group. At the left of the arrow, you have 2 atoms of potassium, and at the right of the arrow, you have 2 atoms of potassium. At the left of the arrow, you have 2 atoms of oxygen, and at the right of the arrow, you have 2 atoms of oxygen. These numbers 1, 2, 1, 2 are known as coefficients. These numbers in front of the compounds are known as coefficients. So the coefficient of sulfuric acid is 1. The coefficient of potassium hydroxide is 2. The coefficient of potassium sulfate is 1. And the coefficient of water is 2. These coefficients are also referred to as moles. So here you have 1 mole sulfuric acid reacting with 2 moles potassium hydroxide to give 1 mole potassium sulfate and 2 moles water. These moles can also be presented as ratios. So the ratio here is 1 is to 2 is to 1 is to 2. We want to see whether the number of moles in this chemical process are consistent with the mole ratio as we have in the balanced chemical equation. Now in the statement we have that 0.6 mole sulfuric acid reacted with 0.4 mole potassium hydroxide. Let us compare the mole ratio in the chemical process with the mole ratio in the balanced chemical equation. Now in the balanced chemical equation, for every mole of sulfuric acid, you need 2 moles of potassium hydroxide. Now, is this mole ratio consistent with what you have in the chemical process? Of course not. If you have 0.6 mole sulfuric acid, you would need 2 times 0.6 mole potassium hydroxide, and that will give you 1.2 mole potassium hydroxide to give you 0.6 mole potassium sulfate and 1.2 mole water. This mole ratio is consistent with the mole ratio you have in the balanced chemical equation. Whereas you ought to have had 1.2 mole of potassium hydroxide, you have only 0.4 mole of potassium hydroxide, meaning that potassium hydroxide would finish first. So potassium hydroxide is the limiting reagent. That answers the question A. Potassium hydroxide is the limiting reagent. Since potassium hydroxide with 0.4 mole is the limiting reagent, it will have to determine the number of moles of the products formed. So, when you have 0.4 mole potassium hydroxide, it will require 0.2 mole sulfuric acid to give 0.2 mole potassium sulfate and 0.4 mole water. So the second question, how many moles of potassium sulfate are formed? 0.2 mole. Now see, what is the mass of potassium sulfate formed? To solve this problem, we use the formula mole potassium sulfate is equal to mass potassium sulfate divided by mass of 1 mole potassium sulfate. We are looking for mass of potassium sulfate, so we use mass as the subject of the formula. We now say mass potassium sulfate is equal to mole potassium sulfate times mass of 1 mole potassium sulfate. Here we first determine mass of 1 mole potassium sulfate. We do that by using the periodic table to find the relative atomic masses of the elements present in the compound potassium sulfate and multiply the relative atomic masses of the elements by their respective number of atoms. So we have potassium times 2 plus sulfur times 1 plus oxygen times 4. The relative atomic mass of potassium is 39 times 2 plus the relative atomic mass of sulfur is 32 times 1 plus the relative atomic mass of oxygen is 16 times 4. 39 times 2 is 78 plus 32 times 1 is 32 plus 16 times 4 is 64. Add all these to get 174. So 174 grams of potassium sulfate is equal to 1 mole of potassium sulfate. Then we proceed to using this formula. Mass of potassium sulfate is equal to mole of potassium sulfate, which we have gotten to be 0.2 times times mass of 1 mole of potassium sulfate, which we have gotten to be 174 grams. And that will give us 34.8 grams. So the mass of potassium sulfate formed in the chemical process is 34.8 grams. Please like, share, and subscribe. See you next time, and thank you very much.